All right, so there are 31 participants. Well, I'll begin because I have just borrowed time from Amresh sir for 10 minutes. I'll try to finish the biconcave lens also. Sorry, there's some connectivity issue, so the last meeting collapsed. So we were discussing what is the difference between a biconvex lens and a plano-convex lens. Not that you need to know anything about the plano-convex lens, but just as a way of illustrating the difference. Distinguishing the lenses is one kind of question that is asked in the board once in a while. So the way they expect you to find out in one of the two ways. One is through the ray optics part of it, and other is through just the touch aspect of it. The touch aspect of it, I remember it being asked only once or twice in the last 10 years. So basically, if you have a convex lens, by feeling the lens, by just touching the lens, you will be able to feel the bulge. Okay, so that is going to tell you that this is a biconvex lens. Whereas in the case of a biconcave, when you feel the side of the lenses, you are going to be able to feel that there is a curvature that is inward dipping. So therefore, you can figure out the difference between these two types of lenses. From the ray optics part of it, anyway, I have given you an introduction to biconvex lens. So now let's look at how a biconcave lens can be similarly envisaged. So if you take the curving glass spheres, so these are, if you imagine these to be two equiradii glass spheres, then if you look at the space in between these two glass spheres, okay, and this is where the glass refracting surface is, then that makes your biconcave lens. Okay, because both surfaces, the one on this side and the one on that side, it's easy to see that it is made out of a part of the sphere thereof. Okay, and similarly, if you make a lens with just one side of it spherical in this manner, then this kind of a lens would of course be called a plano concave lens. Okay, now just to show you a small illustration of how you can find out the difference between these two lenses in terms of what they do to the light that passes through them. I'll just draw a figure over here. The standard figure that is usually in all kinds of ray optics is an eye. Okay, and now I'm going to use a biconvex lens on top of this. You should be able to see it over there. So do you see the effect of using a biconvex lens? So if I carefully bring that closer to you, it's going to continue enlarging the object. All right. So that is one way in which you can distinguish between a biconvex and a biconcave. So what does a concave lens do? A concave lens, when it is placed, so you see the the actual size of the image, and then I move the biconcave lens, You see the effect of it, right? And as I bring the lens closer and closer to the camera, you can see that the image diminishes further and further. Okay, so this is the image formation difference between a biconvex and a biconcave. A biconvex always enlarges the image, and a biconcave diminishes the image. In fact, these two lenses I found interestingly are complemented with each other. So their curvatures, the radius of curvatures are either similar or close to being similar. So when I slide one above the other, we have an interesting effect. It actually goes back to the same size as it was before. So whatever diminishing, so this time I have put the concave, biconcave first, and then I slide the convex above it. So what happens is whatever diminishing the biconcave does, the biconvex readjusts it. So how this effect happens and how can we understand the diminishing and the enlarging factors, these things we will pick up in the next class, which will of course be on Monday. So you can have a happy boring Sunday sitting at home doing nothing. So we will see that. Yeah, if there are any
Just
questions,
try to make
if there are any questions you want to see it again, I can do it. I have a few more minutes now, if anybody is interested. Saumitri is asking if they are both. Yeah, what happens with plano lenses? I see we don't have all types of lenses available with us, so I can't show you in terms of practically what happens with plano lenses. But once we have worked out the ray optics, how does the individual ray of lights behave when they pass through, then it should be possible for us to, from that information, figure out what happens when there is a plano convex or a plano concave or concavo convex and all sorts of things. Then the exploration is open. Okay, so we will stop now. You can go for your English classes. Have a nice weekend. See you on Monday.